Okay, I want to show you the construction of an involute of a circle. The construction of an involute of a circle. The circle we are using has a radius of 20. The radius of the circle we are using is 20 mm. So the construction goes as follows. So the first thing you need to do is to draw a circle of radius 20 mm. Draw a circle of radius 20 mm. So I'm going to draw a horizontal line here. So draw a horizontal line. So this is an horizontal line. Then draw a vertical line. Draw a vertical line so that we can have the center of the circle. Okay. Then take a radius of 20 mm on your ruler. Radius of 20 mm on your ruler, and draw the circle. So put it at this point and draw a circle like this. Okay. So the circle has been drawn. Then divide the circle into 12 equal parts. Divide the circle into 12 equal parts. So I'm going to use my set square 30 degree by 60 degree set square to divide this circle into 12 equal parts. Okay. Okay, so the circle has been divided into 12 equal parts. So we need to label the circle now. We need to label it. Okay, so I've numbered the points on the circle. So from this point is the initial point. So we call it point P, this point here. So I called it point P is the initial point. Is the initial point. So others from here we have 1, 2, 3, 4, 5, 6 up to 11. So this is the initial point. So what we are going to do now is that draw a line at this point, a straight line at this point. So that straight line should be called PQ and to be a tangent to this circle. So what I mean is this. So draw a line from here. Draw a straight line. Okay. Now let's call this line. So let's call it PQ. So this is line PQ. This is line PQ. Now, as you have divided this circle into 12 equal parts, you are going to calculate the circumference of this circle. So whatever you get, you measure it on line PQ. So I've calculated the circumference. So that is 3.142 times 40. The diameter is 40. Okay, so and that gives us approximately 126 mm. So you are going to measure 126 mm on this line PQ. So this is where I have 126 mm. Is 126 mm. Okay, so the next thing that you need to do is that we are going to divide this line, this point from here to here. We are going to divide it into 12 equal parts, as we have divided the circle into 12 equal parts. So we divide, this is the circumference of the circle. So let me call this point, let me call it PQR. Let me call this point, let me call it R. Okay, so this line PR from P to R, so we divide into 12 equal parts as we have divided this circle into 12 equal parts. So that's what we are going to do now. Okay, the line has been divided into 12 equal parts. PR, which is equal to the circumference of this circle, has been divided into 12 equal parts. So the next thing that we are going to do is that it has been divided and it has been numbered from 1 prime to 12 prime. So next thing we are going to do is that we are going to draw a tangent or tangent to each of these points, So we are going to draw a tangent to each of these points on the circle. Don't forget that a tangent is always at a right angle to a line drawn from the center of the circle to any point on the circumference of the circle. So mean that we have to make use of your 60-degree and 30-degree set square. So if I'm to draw a tangent to this point now, we are moving in this direction. We are going to move in this direction. So if I'm to draw a tangent to point 11, now, so I have to use my 30-degree set square, the set 30-degree side of the set square like this, so that the line will be at a right angle to this point. So it goes like this. So next is point 10. So for me to draw a line that will be at a right angle to this point 10, I have to make use of the 60-degree side. This is it. This is the 60-degree side. So I have to make use of that. So it goes like this. Then for point 9, so this is horizontal line. So I will just use the vertical side, this side of the set square, and it goes like this. Okay. So next we have what? We have that of 7. So sorry, that of 8. So I will use 30-degree side. 30-degree side. No. I have to make use of 60-degree side. 60-degree side is the one that will work. So I have to turn it like this. So from this point, so we draw this line. Then for 7, so I can use 30-degree side. I can use 30-degree side. This is it. So it goes like this. So that line is perpendicular to point 7. And also for point 6, I will just draw a horizontal line from point 6 here. So this goes like this. Okay. So now, so for point 5, I have to make use of 30-degree side. This is it. I have to make use of 30-degree side. So it goes like this. Okay. Then for point 4, so I have to make use of 60-degree side. So I have to turn it. So it goes like this. Okay. And for point 3, so it's a vertical line. That will be a vertical line. So it goes like this. Okay. Then for point 2, so I have to make use of 60-degree side of the set square. Okay, so this goes like this. For point 1, so I have to make use of 30-degree side. So this goes like this. Okay, so we have drawn tangent to each of the points on the circle. So don't forget that a tangent is a line that is perpendicular to a line drawn from the center of the circle, and that the line drawn from the center of the circle is the radius of the circle. So that tangent must be at a right angle to the radius drawn from the center of the circle. So the next thing we are going to do now is that we take our compass. Take your compass, put it as point P here. At point P here, this is the starting point. Put it at this point P and extend to 1' on this line. Extend it to 1' on this line from point P here. From this point P here, so you extend to 1' on this line PR, which is equal to the circumference of the circle, and has been divided into 12 equal parts. Has divided this circle into 12 equal parts. So from point P, extend to 1' on the line. Extend to 1' on the line, and you put your compass at point 1 on the circle. Put your compass at point 1 on the circle, and you make an arc on this line 1. On this line 1, make an arc. So this is the point on line 1. This is the point on line 1. Then from P to 2' on this line, extend to 2' on this line. This is the point here. So here is the point. This is the point here. Here is the point. Then you put it at 2. Put it at 2. This is point 2, and you make an arc on line 2 on the tangent to point 2. On the tangent to point 2. So this is the point. So I will call this point. Let's call this point. Let's call it P1, and this is P2. this point is P2. Okay, so the next is from P again, you extend to 3 prime on this line. So this is 3 prime. Okay, so put your compass at point 3, so you make an arc at this point. Make an arc here. So this point here, where the arc touch the tangent drawn from point 3, so we call it P3. This is P3. Okay, so next from P to 4, from P to 4 prime on this line, so put it at point 4 here and make an arc on the tangent to point 4. Okay, so it continues like that. You do it like that to point 12. That is what? Okay, to point 11. It will not get to 12, but to point 11. So this is P, this will be P4. So you continue like that. Okay, so all the points have been obtained. So we have P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, and P12. So all you need to P12, you don't have to take a radius of P from P to point 12 prime. So everything, by the time you move, everything will come to this point. So that's why I said just take it up to P11. So that is all you need to do. So the next thing we are going to do is to join the point together. To join the point together with the use of our French curve. So we are making use of the French curve to join this point together. So it goes like this. So we join point P with P1. We join P with P1. P with P1. It goes like this. Then we have P1 joined with P2. Okay, so and then so we move on like this. So here we have P2 joined with P3 and okay, so this is joined together with this. Okay. Okay, so we are making use of the French curve to form the involute. Okay, so we join point 11 with point 12 and it goes like this. Okay, so this is the involute. So this shape, this curve is the involute. So another thing that you may ask to do is that you may be asked to construct a tangent to this involute, at a given point. So they may give you a point that you measure a distance from here to a particular point here. So just make sure you read the question and understand it before you answer. So I'm going to put a point here. And this point I will call it point N. So this is point N. So let's call the center of the circle, let's call it center C. So what you need to do now is that join CN together with a straight line. Join CN together with a straight line. So it goes like this. Join them together with a straight line. Okay, so after this, so we are going to construct a semicircle. We are going to construct a semicircle that will touch point N and point C. So to do that, we have to bisect CN so that we can locate where we are going to put our compass to draw the semicircle. So this is what we are going to do. So bisect CN. So we have put your compass at C and extend the compass to any convenient radius. So draw an arc left and right of the line, and then you put the same radius at point C here. Put the same radius at point C and draw an arc here, draw an arc here. So by setting my ruler at the point of intersection of the arcs, so I can obtain a line here, or the midpoint of the line CN, So I will now put my compass in. Put your compass at this point and extend to N or C, and draw a semicircle. So draw a semicircle. So semicircle goes like this. Okay, so this is the semicircle. So the semicircle, you touch this circle, the given circle, you touch the given circle at this point. You touch at this point. So I will call this point, call it point M. Call this point, call it M. Okay, so call it M. You now join MN together with a straight line. Join MN together with a straight line, so it goes like this. And this line MN is also a tangent to the given circle. So draw a line like this from here to here. So this line MN, which is also a tangent to the given circle, is also a normal. Is a normal to the involute. Is a normal to the curve. So I'm going to write normal here in case you are asked to indicate a normal to the curve. So you need to know that this line is a normal to this involute. So this is normal. So this is a normal to the curve. Now, so to draw the tangent so a tangent is always perpendicular to a normal. That means it's at a right angle to the normal. So I will make use of this protractor. So make sure the 90-degree line is on the normal. So I'll move it up a bit so that you can see the point. So draw a straight line. Draw a straight line like this. Draw a straight line. Okay. So draw a straight line. So this line, so let's call it ST. So this line ST is the tangent to the involute. So line ST is tangent to the involute. So the construction of the involute of a circle is as simple as I explained here. So all you need to do is to practice. So look for standard questions and practice. And then for you to learn more, subscribe to my channel. Just go to YouTube and type Tijani Olawale Ismail. Subscribe so that whenever I upload a new video, you get a notification. So like the channel and share with friends who are technical drawing students. So the construction of an involute of a circle is as simple as I said it here. Thank you.